All right, everyone. Welcome to a review of the first section, 1.1. This video was missing. I had some trouble in last semester, so I have to re-record it right now. Um, the key thing right here is that all of the dates on these are incorrect, right? They were first done during COVID, so they have the old dates on them. I guess at some point I need to go ahead and change them or at least remove them. Um, so basically, you can just ignore all the dates on there. The dates in Canvas should be correct, although it looks like I need to correct those as well. But the dates in Canvas generally are correct. All right, so section 1.1, what is statistics? I need to hit the play button right here. All right, statistics is the study of the procedures for collecting, organizing, describing, and interpreting information from data. The basic idea behind statistics is that data by itself is not that useful. But if you take data and you work the data, you put it in ways and organize that data, it can actually tell you a very powerful story. And so that's the basic goal behind statistics. We often think of statistics in terms of the interpreting of information and the projecting of information, because what's one of the powerful outcomes that we can have from statistics. And so again, that's why we study these topics right here. Some of the major aspects of statistics include data, which is simply values that we collect about things we call variables. Data comes in many forms. They can be text, they can be numbers, they can be pictures, they can be colors. Basically anything that you can associate or have a value that you associate with your variables. Speaking of variables, variables are the characteristics of features of individuals that we are interested in. For example, if I'm interested in students, your variables may be, for example, the GPA, the current courses that they're taking, their major, their hopes and dreams. All those things right here are your different variables. So you can imagine if I have two different students, student A may have as their major mathematics, while student B may have their major as business. I don't know business majors. I should know one. Marketing. There we go. Marketing. And so basically right here, each variable is tied to the individual or thing that we are talking about. And then, generally speaking, when it comes to statistics, we are focusing or studying individuals. And so, what that means for us right here is that there is something. It's not always a person. It can be a school. It can be a classroom. But whatever that thing is right here, we call it an individual. And what happens right here, generally speaking, they're either people or things. And what happens is we measure or we observe them to create a variables, and that variables becomes our data. And from that data, we can then do statistics to analyze and understand what that data is trying to tell us. Don't forget that you can always send me an email or message me if you have any questions. And also remember that the university has several assistance portals for you. If you go into iRattler, at the very bottom, there's this thing called Tutor Ocean, where you can get a free tutor if you need help. Also, you can come to my office hours, Fridays from 11 to 1, or by appointment if you need help. All right, types of variables. Variables are broken into two groups, qualitative and quantitative. One with an L, one with a T. Qualitative variables are variables that do not use numbers to describe. So, in other words, qualitative variables cannot answer how much or how many or how long, because you don't associate numbers with these things. An example of a qualitative variable might be eye color. right? Eye color is just simply a label. It might be brown, it might be hazel, but basically you can't attribute a number to that variable. On the other hand, quantitative variables do tell you how much or how many. And again, the key thing right here is they return numerical values. So your variables are broken into two groups: qualitative, i.e. giving labels, and quantitative, as in NT, as in numbers. All right, which of the following are qualitative and which of the following are quantitative? You have to say it slowly to get the L and the N in there. A person's age is quantitative because it is a number. Someone might be 5 years old, it may be 5.5, but it still is a number. A person's gender will be qualitative because it is simply a categorical variable. It is not a number. Again, anything that's not a number falls into qualitative. Your mileage in your car, again, how many miles you have driven, again, think about how many or how much, well, not how much, but how many, and so that's going to be quantitative. And then your color of your car will be qualitative. Again, we're just talking about a quality of the car. We're giving it a label. You know, literally, you can just make up a color. You can call it diamond. What kind of crazy color? Diamond gem black. You know, they just mix stuff up for those cars and say, hey, that's the color of the car, right? It's just a label. Now, here's the thing. Both qualitative and quantitative variables are broken down into two subcategories. Qualitative variables can either be ordinal or nominal. We'll get to the quantitative in a second. When we say ordinal, what we mean right here is that the labels have a natural ordering. For example, if I ask you to rate a class experience, I'll give it a ranking. If I put on there, the ranking can either be poor, fair, good, or excellent, you can recognize that there is a basic ordering in there. Now, I'm not saying, for example, excellent is twice as good as good. I'm not saying that, but literally, you know that excellent is better than good. So there's an ordering in there. On the other hand, your nominal variables do not have an ordering, right? If you ask a question, do you like the color orange? The answer is yes or no. Those can't be ranked. You can't say yes is better than no, or yes is larger than no, or there's an increase to go from yes to no, right? And so again, those cannot be ordered. Again, the O in ordinal should remind you of the word order. The N in nominal should remind you of the not, as in you cannot order them. Which of the following variables are ordinal and which are nominal? The state that you reside in, that is going to be nominal. Unless, of course, you know state that's the best. I don't know. But they can't be ordered. There's no natural ordering. Putting them, for example, in alphabetical order is not really ordering them. That doesn't tell you which one is better or which one is larger in size. It doesn't tell you any of those things. On the other hand, gender, again, this will be nominal because, again, there's no natural ordering. There's no natural ordering to those things right there. But your letter grades in your class, that will be ordinal because the grades do confer a meaning. A grade of C is better than a grade of F. A grade of B is better than a grade of D. So there is an ordering to them. And then your size of your soft drink, right? You can order, was it small, medium, large? I think they got rid of extra large. I think so. But it is ordinal because if you order a large drink, you'd expect to get more than a small drink. And so there's an ordering there. Any questions? Don't forget you can reach out to me. Give me a high five. No, send me a positive word. On the other hand, quantitative variables are broken into two groups as well. They're either ratio variables or interval variables. Your ratio of variables have what is called a true zero which then causes your ratios to have meaningful values. What does that mean? I don't know. What it means is that if you have a ratio variable, I think I have an example right here. If you have a ratio variable, then what happens is, first and foremost, the 0 actually means there's nothing, right? So if I say you have a height of 0, it means you have no height, right? If I say your age is 0, it means you have no age, you have not been born yet. But what it also means is that I can compare different values and have the comparison make sense. I'll come back to interval in a second. And so right here, if you look at the age of a person right here, the age of a person does have a true 0. And so what that means for us, or one of the ways that we can see this right here, is that a 12-year-old person is 4 times as old as a 3-year-old person. In other words, if I take the age of the first and I divide it by the age of the second, the answer I will get is going to be a fixed number. Again, the idea is, because we have a starting point, we can compare different values and the ratio will hold. If, for example, I change to a different variable, I change from years to months, 12 years is 144 months, 3 years is 36 months. If I make this comparison, I will still get an answer of 4. Doesn't matter how I measure them. I could measure them in hours, I could measure them in months, I can measure them in quarters. The 12-year-old person will always be 4 times as old as the 3-year-old person. Okay? The 0 is a starting point, and thus, because everyone has the same starting point, we can compare. The ratio between people will be, or ages will be the same. For a, let me go back twice. For an interval variable, this is not so. For an interval variable, we do not have a true 0, and because we do not have a true 0, ratios of the data points do not carry a meaning. Again, a ratio ends with the letter O, kind of remind you that it has a true 0. O is the number 0. Well, intervals, the N right here, doesn't remind you, it does not have a true 0. So again, looking at our first example, the age of a person right here, you can measure age in years, months, weeks, days, hours. It doesn't matter. They're all equivalent measurements. I could have measured this right here in weeks, divided the weeks, number of weeks for a 12-year-old person by the number of weeks of the 3-year-old person, and the answer would still be 4. On the other hand, temperature is not a ratio variable. Temperature is an interval variable because the 0 is not a representation of actual no heat energy. Right? If something has a temperature of 0, you can actually go below that temperature, right? Fahrenheit 0, you can go to -20. 0 doesn't represent a starting point. It's not a true 0. And again, a key thing right here, you can see this right here, is that if I go from, again, they switched over to Celsius, but it's the same thing right here. 0 degrees Celsius is not a true 0. You can go below it. It's not a starting point for the engine. The actual answer, I believe, is degrees Kelvin. 0 degrees Kelvin, I believe, is your actual true 0. But these two right here, if I go from 10 degrees Celsius to 20 degrees Celsius, or 10 degrees Fahrenheit to 20 degrees Fahrenheit, I am not stating that you're twice as hot. Okay? The ratio of dividing these two things does not have a meaning. So if I divide the two right here, and if I convert Celsius into Fahrenheit, 20 degrees Celsius is 68 degrees Fahrenheit, and 10 degrees Celsius is 50 degrees Fahrenheit. When I divide the two numbers, I don't get an answer of 2. In other words, it's not twice as hot. Okay? So body temperature, again, it's a number, but it's an interval variable. All All right, the height of a person, your height of a person is going to be a ratio variable. Again, if a person is comparing two people, one is 6 foot tall and the other is 3 feet tall, they right here will be a ratio of 2. So literally, if you take the if you had two people who were 3 feet tall and you put them one on top of the other, you get 2 of the 6 foot tall person. This kind of thing only happens in a ratio variable. In a interval variable, this will not happen. Again, if I convert to a different units, inches, again, 6 feet is 72 inches, 3 feet is 36 inches. You still get a 2 when you take the ratio. Again, the important idea right here is that you need to be aware of whenever you're using a numbering system where the 0 is just an arbitrary starting point. Because of human history, we just decided that, hey, this is where our 0 is going to be, right? And so because of that, you have to be aware of that fact. All right, so that takes us to the second half of the section right here. And that takes us into the difference between your population and your sample. A population is the collection or the set of every individual within a group. So, for example, if I wanted to study students at the Florida A&M University, then the population of students would be every single student who is enrolled at the university. I believe that number is around, 11,000 something right now? But literally, that would be the population of enrolled students. On the other hand, a sample is a subset of that population, where some, but not all, of the individuals are looked at. So, for example, remember my population was students at Florida A&M. If I, for example, look at only students who are playing basketball, this would be a subset of the population, and so then this would be a sample. So if I just went, for example, I wanted to learn, maybe I want to know what kind of car students drive, right? Or how many miles students drive to campus, or both. I decided to just go sit outside the Al Lawson Center and wait for students to come out, right? And then as they come out, I give them a survey and I ask them, hey, what you guys drive? Hey, how far you guys drive to get to campus, right? That would be a sample. If, on the other hand, I put out a decree, because I'm all powerful, and I sent out an email to every single student, and I told every single student, you must reply to this email telling me what you drive and how far you gotta drive to campus, and all the students reply, that collection of data, that would be a population. Because I have a response from every student. All right? The thing is that in the real world, we almost never deal with populations because it's very difficult or expensive to get every single person in the population to participate. So often what we do is we take a sample and we use that sample to make inferences about the population at large. And that's the essence of what we call statistics. Now, before we get to that right here, we have to go through two key values. A parameter is a number that describes data from a population. So you remember I sent out that email to every single student and I got every single student to reply. And then I took the average. And then I took the average of the miles driven to class. This number I get, let's say that number is say 10 miles. This number right here, it will be called a parameter. It is called a parameter because it's a description of or from the population. On the other hand, if I only took 10 students at random, and I took the average of those 10 students, so only 10 students, if I took only 10 students, I took the average, and I got a score of, say, 11.2 miles, then this number, this 11.2, is called a statistic. It is a measure of a data that is measure or used data that came from a sample, right? Sample starts with S, statistic starts with S, population starts with P, parameter starts with P. And so that gives us this overall picture right here, where your population is everybody. And if you make a calculation using everybody, then the answer will be, the number will be characterized or called a parameter. On the other hand, a sample is a subset of the population, a smaller group. And if I use that to make a calculation, that answer we get is called a statistic. Again, normally it's difficult to find populations. It's not impossible, right? Normally everyone attends first day of class. So maybe if my population was students in my this section of my statistics class, and everybody came to class, and I asked everybody, hey, how far you drive to campus? And everybody gave me the answer, then hey, I have a parameter. That average I take, all those numbers, those are parameters. But if on the first day, a few students are missing, all of a sudden, this will become just a statistic, because the numbers I'm getting is not from the entire group. Okay? All right, let's do a little bit of practice on our statistics and our parameters. All right, 57% of students at Central High School are female. Identify the individuals of the study. The individuals of the study are all the teachers at the high school. Right? To get this number, they had to talk to teachers. So that's why, therefore, the individuals are your teachers. Identify your variable. Your variable right here will be the gender of the teachers, because this number right here is telling us about the gender. Is it qualitative or quantitative? Well, is gender qualitative or quantitative? Can I apply a number? Can I say how much gender? And the answer is no, and so this is a qualitative measure. Is it ordinal or nominal? Remember, qualitative has two groupings, ordinal or nominal right here. Can gender be ordered? O for ordered. Answer is no, so therefore it is nominal. Does the data come from a sample or a population? Well, 57% of teachers at the high school, so most likely they were able to interview all the teachers at the high school. Normally high school doesn't have that many teachers, so it's possible to get to every single one of them, and so therefore this will be a population. Normally, if it's a sample, they'd actually tell you. So number 57, is it a statistic or is it a parameter? And the answer, the letter P, it is going to be a parameter, because it describes the entire population of teachers. Questions there? Example number 2. In a sample of 100 surgery patients who were given a new pain reliever, 78% of them reported significant pain relief. Yay. All right, what are the individuals of the study? The individuals of the study right here are your 100 surgery patients who were given the new pain reliever. Identify the variable right here. Your variable is going to be the level of pain. High, medium, or low pain relief. Again, this is just one example. You could have had high, medium, low, or none. You could have, but those, I shouldn't say it right here. So is this qualitative or quantitative? Can I say how much pain do you have, or how many pain do you have? Not really, right? And so this is going to be qualitative. We're just labeling the amount of pain that they have. High is just a label. It just means higher than medium, higher than low. It doesn't really actually tell. If I have two patients who have high pain, that does not necessarily mean their pain is the same. Is this ordinal or nominal? Can these be ordered? And the answer is yes, they can. You'd assume that someone with low pain versus someone who has high pain, the person with high pain has more pain. And so you can order the pain levels. Did it come from a sample or a proportion? It came from a sample. What's the underlying population? Now, whenever you ask for a sample, one of those key questions that you're going to ask is, what is the underlying population? Or in other words, where did this sample come from? And the underlying population right here is everybody. And so that's going to be all surgery patients who are given the new pain reliever, not just the 100 in the sample. And last but not least is the 78, a statistic or a parameter. Again, this is a sample, it is a sample, and so it is a statistic. All right. Again, you can ignore the dates on here. Homework 1.1. Homework 1.1, you should be able to get started on that homework right now. Don't wait until right before the test. Go ahead and get started on assignments. Again, I'm just understanding that this is the summer and you guys have work and other things to do, and so we give you a little more flexibility. But the first one should be due on the 22nd, I believe. It's our first due date. But all right, guys, have a nice day.